Okay, welcome everybody. Today what we're going to be discussing is equilibrium. My name is Izza and I'm the founder of Academy Plus. You can check out the website on www.vcetuition.com.au for more information about our services and basically more information about, just free products. There's really good questions online and I'm putting articles on there as we speak. So feel free to come along and visit. Okay, so first of all today we're going to be discussing equilibrium and what equilibrium is. Now equilibrium is really important in industry, okay, because most equations aren't these type of equations. In the past you would have been looking at A plus B giving you some kind of C plus D. Now A plus B would be called the reactant and you would know that C plus D is product. Okay, now normally this would happen at about 100% efficiency. That's theoretical, but sometimes you have different percentages. And you would have known that all of this converts into that, and that it's irreversible. You can't actually convert this and this back into that. Now, what happens in reality in industry cases is that when you first combine two reactants, A and B, they can produce C and D, but then you get to that point, to a certain point where C and D can actually react together and go backwards as well. So that is known as an equilibrium equation. An equilibrium equation is an equation in which you're basically converting this stuff to this stuff, and then this stuff is converting back to the reactants. And therefore you have a system that is continuously dynamic, it's continuously going back and forth, but the concentrations of each of these remain the same at equilibrium. So you'll find that, the definitions that you have to use for equilibrium is that it's a dynamic process. That's the first definition. The second definition that you have to use is that the rate of the forward reaction, okay, so the rate of that reaction, is equal to the rate of the backward reaction, and the concentrations remain the same. So essentially three things. Okay, now let's have a look at something else known as the K value. So there's a value in chemistry and it's known as the Kc, or K value. K value. And what it basically tells you, this is known as the equilibrium constant. Equilibrium constant. So it tells you the extent to which those products are formed, because as you can see, although you have A and B forming into C and D, we don't know when that equilibrium is established. We don't know whether it's established after you've made a lot of C and D, or it may happen when you haven't made a lot of C and D and this rate of the forward reaction is matching the rate of the backward reaction. So we don't know the extent to which we produce products, okay? And so the way of calculating this is to find the K value. So essentially what the K value is, it's defined as, if we just put coefficients in front of these, A, B, C and D, if we put coefficients in front of them, the K value is going to be equal to the concentration of this times the concentration of that. So the concentration is in square brackets, okay? Concentration of C to the power of C, because that's that number there we place to the power, okay? Concentration of D to the power of D, divided by the concentration of A to the power of A, times by the concentration of B, times by little b to the power of little b. So what we're doing here is basically these things here, okay, they describe your products. And these things here, they describe your reactants. So essentially what the K value tells you is the extent to which you've produced products compared to your reactants. So that means that you have two cases. You're going to have, well, you really have three cases, so you can have three different values of K, Alright, you can have K is big. Okay, so maybe I'll do this in a different way. So you have three cases. You have big, average, and small. And in the case where K value is big, that means because it's products divided by reactants, you have a lot of products and not a lot of reactants, so you're going forward. Okay? If, this is average, that's basically like a value in between these two extremes, okay? Which we kind of ignore this one. We look at them from the perspective of either big or small. And small, if we have a small Kc value, remembering that Kc is product divided by reactants. So if we have a small K value, that means that this value goes down. So the product, the numerator is low, whereas the denominator is high, which causes this as an entire number to be small. So that means that you have very little products and a lot of reactants, which means that your K value or the extent of your reaction is going backwards. Okay? So remember, just as a summary, a big K value means that it's going a lot forward, it's going powerfully forward, and a small K value means that it's going backwards. Okay, so essentially that's what we need to do. And remember one more thing, that K values can only be found for equilibrium equations, no other equations, okay? And the only thing that can change K value is the temperature. We'll come back to that in the later tutorials. I hope you enjoyed this presentation, and have a look through all the other videos. I'm sure that they will be helpful for your equilibrium understanding. Thanks.